to take a quick look at how to balance some chemical equations. And this sheet is in the orange crate if you don't have one. And it has the steps for you up at the top. And this is kind of the way that I solve them. It's not the only way to solve them, but it's the way that I do it, and it works a little bit better for me. So the very first thing that I always do is I do a list underneath. So if this is my problem here, I list my elements involved in the reaction. That's the first thing I do. And then I count up the number of atoms of each element that I have in both the reactants and the products. And then I can only change, step 4, it says you can only change the coefficient. The coefficient's the number in front to balance. And then really it's just a guess and check method trying to figure out how many molecules of each compound that you need. Okay? So what we're looking at here is NaCl, which is a compound, sodium chloride. Okay? Then we're looking at F2, which is fluoride, right? So you've got 2 fluorine atoms bonded together. And then we've got this right here, which is NaF, which is sodium fluoride. And then we have a chloride atom over here, chloride molecule over here. So those are what I'm dealing with. Now I cannot change those. All right, those have to stay the same. The only thing I can change is the coefficient, this big number in front. That's the coefficient. So we played a game in class, that PhET simulation, and on the PhET simulation they went ahead and put a 1 in each one of those. Now we don't have to put a 1 there, and you normally, if it's just one molecule of sodium chloride, you will not see a 1 in front of it because 1 is understood. So you have the coefficient, and then don't forget you have a subscript. So what I'm going to do is I'm going to show you what this is, and we're going to draw this out as well. Now we've made models in class, but to help you visualize it, we will look at all the parts of this and how to solve it. So let's do this. Let's list the elements that we have involved. So I've got sodium. So if you want to just list the element symbol, that's fine. I have chlorine, which is an element that's involved in this reaction, and I have fluorine. So those are my elements that are involved, and I like to make a little chart. Again, you don't have to. It just helps keep me organized. These are reactants. This is how many atoms. This is where I'm going to keep my tally. So this is like my tally sheet. And then this is my product. So remember what we talked about just the basic equation. Your reactants are on the left-hand side. So all this over here, these two are my reactants, okay? Sodium chloride and fluoride. And then these two are my products. So this is my product side. So the right side is my product side. The left side is my reactant side. And this little sign in the middle is an arrow. Of course, I typed it. And this little sign, we read this as yields. It's like the equal sign in math. So if it's equals, if it means equals, the number of atoms on one side has to be the same as the number of atoms on the other. And so that's the whole point. What we're trying to do is we're trying to balance this out and see what's going on. So right now, if I look across here, I'm going to count up how many atoms I have. So Na, remember that subscript is 1. So I have 1 sodium atom, and it's bonded to 1 chlorine atom. And then I've got 2 atoms of fluorine bonded together. So I have 1 sodium, 1 chlorine, 2 fluorines on this side. That's my reactant side. And then I've got my product side, so I'm just looking at this side. So I say I've got 1 sodium, and it does help to keep them in order, okay? You don't want to list them separately, all right? Then I've got 1 fluorine, but remember I didn't list fluorine next, so that's down here. They're in different order, and that's okay. And then I've got 2 chlorine on this side, so I'm going to put a 2 here. So if I'm looking for yields, and I know that it has to balance out, because remember we talked about something called the law of conservation of matter. It says that during any change, chemical or physical, and this is a chemical change, this is the way that you write a chemical change, that all the matter in the beginning can't be created or destroyed. It can only be transformed. So it has to be there in the end. So for example, if I have 2 atoms of chlorine on this side, I had to have started somehow with 2 atoms of chlorine. Okay? If I have 2 atoms of fluorine over here, one just doesn't disappear. I have to have 2 atoms of fluorine over here on this side. So again, I'm looking at the number of molecules that I have. All right, so let's talk about that just a little bit. I'm going to use some different colors like our game did on the PhET simulation, and if you want to go look at that, that link is there as well. So let's say I've got a sodium chloride atom. I'm going to use purple for sodium. All right, so there's my sodium atom, sodium, and I'm going to use red for chlorine. Well, it doesn't look purple, does it? I'm going to use red for chlorine. And then that's a molecule, sodium chloride, and then I have F2, so that means I'm going to use blue. Let's see how this works. That's 1 fluorine bonded to another fluorine. Okay, that's 2 fluorines. And over here I've got a sodium bonded to a fluorine. So sodium, I used my purple. So that's a sodium bonded to a fluorine. And then I have 2 chlorine on this side bonded together, and that was my red. So I've used colors. You don't have to use colors, but this is just to help you see what they look like. Okay, so now this is what I have, and this is the count that I did. So what I have to do is I have to change the coefficients in front of here. So again, it's understood that they're all 1 to begin with. So I'm going to pick something that's out of balance. And again, this is where the guess and check method comes in. So I'm going to pick chlorine. Okay, chlorine has 2 on this side. It has to have 2 on this side. The only thing I can change is the coefficient. So if I say, okay, well maybe we started with 2 molecules of sodium chloride. That means that I now have I've added another molecule of sodium chloride over here. Okay? So now I have 2. So I'm going to adjust my count. Okay? I have to adjust our count. I have to keep count of what we're doing. So over here, since I added a chlorine atom, I now have 2 on the reactant side. I still have 2 on the product. Okay? And then my fluorine, I didn't touch my fluorine, did I? But I did change my sodium because when I added another molecule, it was attached. So it kind of drug it along with it. So by accident, I guess you could say, is I actually unbalanced my sodium, which doesn't seem quite fair. But if I go, okay, well let's go fix that then. Or I can fix the fluorine, either one. If I look here, I can come to this side, and if I put a big 2 in front here, now what I've done is I've added another molecule of sodium fluoride. My sodium was purple, and my fluorine was blue. So now I have that. So now again I have to recalculate, okay? So I've got 2 sodiums. So again, I got 2 sodiums over here, got 2 sodiums over here, purple and purple, 2 and 2. And then this one was attached to a fluorine. So now I have 2 fluorine, which is exactly what I wanted. So this is my balanced chemical equation. Now, you will not see these written with a 1 in front of them, but it's really there. Okay? You can write the 1 in front of it, but don't expect to see the 1 in front of it all the time. Most likely it's not going to be anything. No coefficient is assumed it's a 1, just like no subscript here is assumed that it's a 1. So just like in math, you don't write 1A, you just write A equals, right? You don't write 1A equals, you just say A equals. So it's the same type of thing here. Okay? Let's look at this one underneath. So make this a little more simpler. Let's look at number 2. S8O2SO3. So I'm going to list my elements. I have sulfur and I have oxygen. I do my reactants and my products. Reactants are on the left, my products are on the right. And I'm not going to take really a whole lot of time to draw this out, but this means that I have 8 sulfur atoms bonded together. So I've got 8 when I'm making my count, and I have 2 oxygen. Over here, I only have 1 sulfur. That S is a sulfur, so I only have 1 sulfur, and I have 3 oxygen. So they're both out of balance. Well, I'm just going to pick one. It makes most sense because I know that I have to have 8 sulfurs. I'm going to start with this one. So I'm going to have to put an 8 here because I have to have 8 sulfurs. So that 8 goes to that sulfur and it applies to this oxygen. So, but there's 3. So I want you to think about what this looks like. If I have a sulfur atom bonded to 3 oxygen atoms, something like this, there's the bond, something looks like that. If I have 8 of those, if I add another one, think about that. I'm adding, every time I add one of those molecules, I'm adding 3 oxygens. 1 sulfur every time, so I would have 8. If I drew this picture, just did the copy and paste button, right? If I did that 8 times, I would have 8 S's, and then I would have 3 and 3 and 3 and 3, 8 times. So 3 times 8 is actually going to give me 24. So that's going to give me 24 oxygens on my product side. Okay, so my sulfurs have balanced, which is excellent. That's what I wanted. They balanced. But my oxygens are not balanced still, which they weren't balanced to begin with. So I have to go back to this side. Okay, I'm going to go back to my reactant side because that's where they're off. The product side is 24. I had to do that for the sulfur. So I'm going to come back to the oxygen side, and if I put a 12 in here, this becomes a 24. Because O2 molecule is 2 oxygens bonded together. Okay, so if I have 2 oxygens bonded together, and I have 12 of those, then I would end up with 24, because every time I added another molecule of oxygen, I would actually be adding 2 atoms of oxygen. Okay, so now I have the 24 and I have the 24, so my formula is balanced. All right, let's look at this one underneath here. We have 3 elements. I have potassium, I have magnesium, and I have bromine. I have 2 sides. I have the reactant side and the product side. Okay, and now I'm going to do my count. So I'm just going to come down and say, okay, I have 1 potassium, 1 magnesium, 1 bromine. On this side I have 1 potassium, then bromine comes next. I'm going to put it in the bromine spot. All right, bromine, and then I have 1 magnesium. Well, guess what? This one's balanced. You have 1 and 1, 1 and 1, 1 and 1, and you're good. So you're done. You didn't have to do anything. It's balanced exactly the way that it is. So what I want to have you do is on the back side, I want you to do 4, 5, 6, and 7. Now 6 is super difficult, and I'm going to give you a hint. I'm going to put a 2 right here. Okay? You're going to have a lot. Okay, so this is a really, really high level thinking one, and we really probably won't have any of these that are this hard. We won't have any of these that are this hard, but I'm going to give you the hint for that. So if you watch this, you get a little hint, so that'll help you out. The rest of them are fairly easy, so I want you to work through those, and then we're going to go over this in class, and then we're going to go through these as well. So I will give you this sheet tomorrow, and we'll take them in chunks of 10 and just start working our way through them.